I am going to attempt to run through a few trigonometric problem-solving equations, mostly solving for unknown angles. Problem, we are going to solve for theta, this equation. We have cosine minus tangent squared times cosine equals 0. The first thing I want to do is I'm going to factor out a cosine. And then I want to consider, is there a Pythagorean substitution that we can do here? There's not a good one, so we're going to move on. I'm going to split this into two cases using the zero product property. I want to consider that cosine of theta is equal to 0, and I want to consider that the 1 minus tangent squared is 0. If this is 0, or this is 0, or they're both 0, the product of them will be 0. So the cosine theta of 0, if we consider over here, we find that pi halves will make this a true statement. So theta can be pi halves. Over here, we're going to have to take the 1 to the other side. And then we're going to multiply by -1. And so we're looking for tan squared of 1. We can take the square root of both sides. So we get that tangent of theta is plus or minus 1. So if we look over here, we have pi fourths for positive 1. And then for -1, you can consult your unit circle. All right, after consulting the unit circle, we get 4 solutions here, 1 for each quadrant. If you are not contained on 1 revolution, then you would need to add something to this so that you could get all solutions, the infinitely many solutions, as you continue to go around the circle. If you're trapped on 1 circle, then you have 4 solutions, so a very finite answer. Now, let's look over here at cosine's angle being pi halves. If we consider pi halves in this, you will see that pi halves is undefined for tangent, and so we can't allow the pi half to be a solution, so this is just an extraneous solution. So all of our solutions are contained over here. The next problem that we're going to attempt is to show how to determine theta given 8 times tangent theta minus 14 is equal to 6 times tangent theta minus 12. So in typical problem-solving fashion, you want to get all your independent variables on one side, everything else on the other side. One thing to note first, though, is that all of the numbers that we see currently are even, so you could possibly reduce this problem to an equivalent form with smaller numbers by dividing everything by 2. And now I'm going to go ahead and move all my tangents to the left-hand side and the rest of the numbers to the right-hand side. So I'm going to add 7 to both sides first. So this is going to be positive 7 minus 6 is going to be plus 1. I can subtract my tangent from both sides. So I have 4 minus 3 is just tangent. So now I'm looking at tangent of theta is equal to 1. And looking over here at our chart, we have tangent of theta 1 is pi fourths. Now, referring to the unit circle again, we will also find that there is a second solution in which tangent theta is 1. So both of these angles should make this true. And if we are trapped on one revolution, these are the only two solutions. If we can continue to go around, then each of these can have a revolution added onto it with a variable such as pi force plus 2 pi n. And so this can be any number of revolutions that you want to go around. This is the last problem that I'm going to solve. I'm going to solve for theta for cosine of 12 plus sine of theta equals 1/8 times cosecant of 19. I'm going to rewrite my cosecant so that it involves a sine. All right, I can combine these two fractions. They're just being multiplied together. And I can subtract the cosine of 12 from each side. All right, and lastly, I'm going to take the arc sine of both sides. And there we have it. This is our theta. It may not be the prettiest looking theta that we have, but this is our solution. If you type this into a calculator or some other software, it should be able to provide a numerical approximation.